Working with wind-felled trees presents a serious safety challenge, particularly when the trees have become hung up or partially suspended among standing timber. In this task, the combination of a Cranman T1750 forestry trailer and a Suzuki 750 ATV offers an efficient and safe method for clearing these hazardous trees in tight, uneven forest terrain. The Cranman T1750 is designed specifically for professional forestry operations on a small and maneuverable scale. It features a radio-controlled winch with a pulling capacity of 800 kilograms, powerful enough to handle most lifting and pulling operations involved in recovering wind-felled logs. The radio control allows the operator to stay at a safe distance while maintaining precise control of the winch, significantly reducing the risk of injury from unpredictable log movements or tension release. The T1750's stable chassis, articulated steering, and durable crane arm ensure excellent control even on slopes or soft ground. In this operation, the Suzuki 750 ATV provides reliable traction and power, enabling smooth movement through rough forest conditions. Its compact size makes it ideal for reaching tight spots that are inaccessible to larger forestry machines. Together, the ATV and trailer form a versatile unit for timber extraction, combining efficiency, mobility, and safety. Cutting and sectioning are carried out with a Husqvarna 550 XPG chainsaw, a professional-grade model known for its balance, precision, and heated handles, essential for comfortable operation in cold and wet conditions. The saw's high chain speed and optimal power-to-weight ratio make it perfect for cutting dense, heavy wood. The process involves first securing the hung tree with the winch line, applying tension, and carefully pulling it down in a controlled motion. Once the log is safely grounded, it is cut into sections and loaded onto the trailer for removal. This method demonstrates how modern forestry equipment like the Cranman T1750 enhances both productivity and operator safety, turning a traditionally dangerous job into an efficient, manageable, and well-controlled operation. The John Deere 1910E Forwarder represents a revolution in modern timber transport, combining strength, intelligence, and precision. Designed for heavy-duty forestry operations, it offers exceptional load capacity and stability, making it ideal for long-distance forwarding in tough terrain. Its load space can be adjusted with hydraulic stakes for optimal timber handling, while the twin-track rotating cab and advanced comfort ride suspension reduce operator fatigue and improve visibility. The 1910E is powered by a high-torque John Deere diesel engine that delivers efficient performance with low fuel consumption. Integrated with Timber-matic control systems, it ensures smooth boom operation and data-driven productivity, setting new standards for durability, comfort, and smart forest logistics. The Cranman. From towering forest logs to finished, precision-cut boards, this is the journey of wood through a modern sawmill. It all starts at the merchandiser infeed, where advanced sensors analyze each log's species, size, and quality. High-speed saws cut them to the required lengths before sorting them into species and size bins for maximum efficiency. Logs then move toward the hew saw infeed, where automated machinery and skilled operators transform them into rough boards with exact dimensions. Every byproduct, bark, chips, and sawdust is collected and reused, ensuring zero waste across the operation. Next, the rough or green lumber is loaded into massive dry kilns, where precise temperature and humidity cycles remove moisture, improving stability and durability. Once kiln dried, boards pass through the planer line, where cutting heads and blades smooth every surface to a fine finish. Automated trimming saws cut the boards to their final dimensions, optimizing both value and consistency. Finally, the boards are stacked, banded, and wrapped, ready for distribution. Each piece is identified by species, length, and grade, ensuring full traceability from forest to customer. This aerial journey reveals how modern sawmills combine technology, precision, and sustainability to transform raw logs into high-quality lumber that powers global construction, design, and woodworking industries. The WindLine 16 CNC machining center is designed for high-precision processing of solid wood arches, window components, and complex frame structures. The operation begins with a complete rough arch loading, followed by a precise head cut using the 5-axis machining unit, capable of handling intricate geometries with exceptional accuracy. The machine performs drilling and roughing operations, efficiently removing material while maintaining surface integrity. The integrated NC chip deflector ensures perfect dust and chip extraction, keeping the work area clean and the tool path unobstructed. During production, hidden tool change operations enable uninterrupted workflow, reducing downtime and increasing productivity. The system continues with glazing bar grooving, internal profiling, and glazing bar detachment and removal, ensuring flawless component separation. For finishing, the head profiling unit shapes precise contours with the mini Zinken profile, creating strong and accurate joints. The multi-zone locking system automatically repositions clamps, optimizing hold and accuracy during complex machining sequences. The external roughing and profiling stages define the final outer shape, enhanced by a reinforced chip deflector and aluminum shield that extend operational time and protect sensitive components. Finally, during arch offloading, each part exits the system with perfect finishing quality, clean edges, smooth surfaces, and tight tolerances. The WindLine 16 combines advanced automation, intelligent clamping, and high-speed 5-axis control to deliver superior performance in solid wood manufacturing. A 5-axis CNC machine for wood chairs provides unmatched precision and flexibility in furniture manufacturing. Using simultaneous multi-axis control, it can mill, drill, and carve complex curved surfaces and joints from solid wood or laminated components. The machine's spindle and rotary table allow cutting from multiple angles in a single setup, reducing repositioning and ensuring consistent accuracy. Ideal for chair legs, backs, and seats, the system integrates automated tool changes, vacuum clamping, and high-speed spindles. This advanced machining center enhances productivity, repeatability, and finishing quality, enabling mass customization and seamless production of ergonomic, high-end wooden chairs. The 3-spindle 5-axis CNC machining center is a highly advanced system designed for efficient and precise processing of wooden chairs, furniture components, and curved structural parts. Equipped with 3 independent spindles, the machine can simultaneously perform multiple operations such as cutting, drilling, milling, and contouring on different sides of a workpiece, dramatically reducing cycle time. The 5-axis configuration provides full flexibility, allowing the spindle head and rotary table to move and rotate across complex angles. This makes it ideal for sculpted and organic furniture shapes such as chair backs, armrests, and legs. Each spindle is controlled through synchronized motion, enabling simultaneous multi-part machining or parallel processing of identical parts for mass production. The system features automatic tool changers, vacuum clamping tables, and servo-driven rotary axes for superior stability and accuracy. Smart sensors continuously monitor cutting load and spindle position, ensuring consistent precision even on intricate 3D surfaces. The machine's software interface supports CAM integration, allowing designers to import 3D models directly and generate tool paths optimized for wood density and grain direction. For dust management, a high-efficiency extraction system with chip deflectors maintains a clean working area, extending tool life and improving surface quality. The rigid gantry frame ensures vibration-free operation, while high-speed spindles, often exceeding 18,000 revolutions per minute, deliver excellent cutting finish on hardwood, plywood, and composite materials. Used extensively in chair production, interior decor elements, and artistic woodworking, the 3-spindle 5-axis CNC machining center combines speed, precision, and automation. It eliminates manual repositioning, guarantees repeatability, and produces perfectly contoured components ready for assembly or finishing. This integration of multiple spindles and axes represents the future of high-end woodworking: fast, flexible, and exceptionally accurate. The production of wooden furniture is a highly structured and precise process that combines traditional craftsmanship with modern industrial technology. It begins at the descortazadora, where the bark is removed from logs to prepare them for cutting. The clean logs move to the aserradero, or sawmill, where they are sliced into boards and planks of various dimensions. During sawing, every subproduct, bark, sawdust, and wood chips, is collected and reused as biomass or compressed into briquettes, providing valuable thermal energy for the plant. Tool performance is critical in the sawmill, hence maintenance of cutting tools is performed every 4 hours to ensure accuracy and efficiency. The processed timber is then moved to the storage area, awaiting the drying phase. Controlled kiln drying or air drying reduces the moisture content to an optimal percentage, verified through humidity measurement, ensuring the wood's stability and preventing future warping or cracking. Once dried, the lumber proceeds to planing and trimming, where surfaces are smoothed and rough edges removed. The next stage is preparation, which may include defect cutting, length calibration, and part selection according to furniture design requirements. The molder shapes decorative profiles and structural elements, followed by gluing and calibration to achieve precise thickness and flatness. Quality assurance plays a vital role at this stage. The controlled calidad team inspects each component for surface defects, dimension accuracy, and bonding integrity. Once approved, parts move to the machining section, featuring advanced CNC equipment such as the Morbidelli pantograph, which performs 5-axis routing, drilling, and shaping for complex joints and contours. The sanding machine ensures a smooth, uniform finish, preparing surfaces for the final stages. Production efficiency is supported by waste recovery systems. Dust and chips are collected and compacted into briquettes, supplying thermal energy back into the process. This closed-loop system maximizes sustainability and minimizes waste. The assembly armado phase follows, where components are joined into frames, doors, or complete furniture structures. Skilled technicians verify alignment and stability before transferring each piece to the painting and finishing section. Here, wood surfaces undergo staining teñido to achieve the desired color tone, followed by lacquering lacado for surface protection and gloss. These coatings enhance both durability and aesthetic appeal, giving furniture its final character. After curing, each piece passes through a final inspection and touch-up process. Quality supervisors ensure uniform color, flawless surfaces, and structural integrity. Only then is the furniture packed and sent to the dispatch area, despacho, ready for distribution to retailers or customers. In this Boston facility, every stage, from log debarking to final finishing, follows a continuous workflow, integrating mechanical precision with artisanal care. The use of automated systems, moisture control, and high-performance CNC machinery guarantees consistent quality. At the same time, rigorous tool maintenance and energy recovery through briquettes reflect the plant's commitment to efficiency and environmental responsibility. Thus, the production of wooden furniture is not merely manufacturing. It is a balance of technology, sustainability, and craftsmanship, transforming raw timber into elegant, long-lasting pieces that define interior spaces. The Holzer Multirex represents state-of-the-art 5-axis CNC technology for advanced woodworking applications. Designed to deliver precision, flexibility, and speed, the Multirex offers nearly unlimited machining capabilities, meeting the complex demands of modern production. This system embodies Holzer's extensive market expertise and sets new standards in CNC processing for window and door manufacturing. Equipped with a powerful 5-axis head, the Multirex allows multi-dimensional machining in a single setup, minimizing repositioning and ensuring consistent accuracy. Its robust frame construction guarantees vibration-free operation even at high feed rates, while dynamic servo drives enable rapid and smooth axis movement. The integrated control software provides intuitive, ergonomic operation, allowing precise toolpath programming, automatic optimization, and real-time simulation of machining sequences. With exceptional cutting performance and reliability, the Multirex ensures exact edge quality, perfect fitting joints, and seamless surface finishes on solid wood, panels, or composite materials. Tool changing systems, automatic workpiece clamping, and intelligent dust extraction contribute to efficiency and operator safety. Combining industrial productivity with workshop versatility, the Holzer Multirex stands as the ultimate CNC machining center for manufacturers aiming for economic performance, flexibility, and uncompromising precision. All-style cabinet doors integrates advanced manufacturing technology with precision woodworking. The production line features CNC routers and digital measuring systems that maintain dimensional accuracy within 0.2 millimeters. Each solid wood panel undergoes automated milling, profiling, and edge routing before entering the sanding process. Skilled operators perform manual inspection, followed by puttying and fine sanding to remove cross-grain scratches and tooling marks. Moisture content and surface flatness are continuously monitored to ensure stability during finishing. The dovetail drawers and frame joints are assembled with controlled compression for optimal structural integrity. This fully in-house process allows tight quality control, faster lead times, and superior fit and finish. All-style system combines digital precision with craftsmanship for durable, high-performance cabinet components. NG added. The Nesto Machine X Limosa ASAP collaboration represents a fusion of advanced woodworking technology and refined craftsmanship. Designed for the production of premium wooden furniture and architectural components, this partnership focuses on achieving precision, efficiency, and high aesthetic standards. At the core of the process is CNC-controlled machinery from Nesto Machine, capable of milling, drilling, and shaping complex wooden profiles with micrometric accuracy. The equipment integrates multi-axis control, automatic tool changers, and optimized dust extraction systems, ensuring a clean and consistent production environment. Limosa ASAP, known for its expertise in solid wood design, utilizes these machines to create elegant chair frames, tabletops, wall panels, and customized furniture elements. Each piece undergoes sanding, gluing, and surface finishing operations under strict quality supervision. The combination of Nesto's automation technology and Limosa's craftsmanship results in wood products that are both technically flawless and visually refined. Together, they exemplify the next generation of industrial woodworking, where digital precision meets traditional artistry, producing sustainable, high-quality wooden creations ready for contemporary living and architectural spaces. The Hiroshima armchair in walnut with urethane clear finish embodies the precision and elegance of Japanese woodworking, elevated through a meticulous production process. Each chair begins with the careful selection of solid walnut, chosen for its consistent grain and natural tone. The wood is then seasoned and kiln-dried to achieve ideal moisture balance, ensuring dimensional stability over time. Next, craftsmen perform precision cutting and CNC shaping. forming the chair's distinctive curved backrest and arm structure from a single continuous piece of walnut. These components are hand-sanded to achieve the smooth, organic transitions that define the Hiroshima series. Once assembled using traditional joinery techniques, the frame is finished with a urethane clear coating, a process involving multiple layers of fine spraying, controlled drying, and hand polishing. This enhances the natural depth of the walnut while providing durable protection against wear and moisture. The upholstered seat is handcrafted separately, with foam density and fabric tension adjusted for ergonomic comfort. It is then precisely aligned and fitted into the wooden frame, ensuring perfect continuity between fabric and structure. Through this seamless blend of digital precision and artisanal craftsmanship, Maruni's Hiroshima armchair stands as a symbol of warmth, refinement, and timeless Japanese design. The modern CNC automatic wood lathe machine precisely turns wood into symmetrical and complex shapes with high accuracy. Equipped with multi-axis control, it performs cutting, grooving, and sanding automatically. The machine ensures consistent quality, smooth finishes, and fast production, ideal for making furniture parts, columns, balusters, and decorative wooden components. At Torneria Los Pitoches de Mi Cama, the process of wood turning is carried out with remarkable technical precision and craftsmanship. Each piece begins with a careful selection of raw timber, chosen for its density, grain pattern, and moisture stability. The logs are first rough cut and mounted on a CNC-assisted lathe where the shaping process begins. The lathe operates at variable speeds, allowing the craftsman to control cutting depth and feed rate to achieve smooth, concentric profiles. During the turning phase, specialized gouges and chisels are applied at specific angles to form curves, beads, and tapers according to the product's design. Continuous monitoring of vibration and tool wear ensures dimensional accuracy and a flawless surface. The process includes successive sanding stages, starting with coarse grit and progressing to fine micron abrasives to obtain a perfectly smooth texture. For detailed ornamental work, manual lathes and pantograph systems are employed, blending traditional hand finishing with modern precision. Depending on the final use, components may undergo polishing, staining, or varnishing with UV-resistant coatings for durability. Every finished part is inspected for geometric precision, surface uniformity, and balance. This combination of modern CNC technology and artisanal control defines the identity of Los Pitoches de Mi Cama, producing wood components and decorative elements that meet exacting technical and aesthetic standards for furniture, stair balusters, and interior design applications. The CKD hollowing system is designed for precision internal machining, enabling efficient hollowing of metal or composite parts. Using advanced cutting tools and automated control, it ensures uniform wall thickness, smooth internal surfaces, and high dimensional accuracy for components in aerospace, automotive, and mechanical engineering applications. Wood turning a short vase with a long neck requires a blend of artistic control, engineering precision, and a deep understanding of material behavior. The process begins by selecting a stable, well-seasoned block of hardwood, typically maple, cherry, or walnut, chosen for its fine grain and structural uniformity. The blank is first mounted securely on the lathe between centers to ensure balance during initial shaping. Using a roughing gouge, the exterior of the form is turned to a symmetrical cylinder. The shape of the vase begins to emerge through careful passes, defining the base, the curved body, and the transition into the slender neck. Once the outer profile is refined, the next stage involves hollowing the form, which in this project is done from the bottom first, before creating the opening. This method allows the craftsman to maintain rigidity in the neck area during hollowing, reducing vibration and ensuring a more stable cut. A Forstner bit, or specialized hollowing tool, is used to open the cavity, working gradually deeper while monitoring wall thickness using calipers or laser-guided measuring systems. The goal is to achieve an even, lightweight interior without compromising strength. And Satan. After hollowing the interior from the bottom, the piece is reversed on the lathe using a chuck or jam chuck setup. This allows access to the top portion, where the neck opening is carefully turned and refined. The narrow neck requires precision and light tool pressure, often shaped with spindle gouges and fine scrapers. The transition from the bulbous body to the neck must be fluid and visually harmonious, highlighting the natural wood figure. At this stage, the vase's proportions are fine-tuned. The long neck is gradually thinned to its final diameter, with attention to taper and curve continuity. A shear scraping technique helps achieve a smooth surface that minimizes sanding. Once the final profile is achieved, the piece is sanded through progressively finer grits, starting around 120 and progressing to 600 or higher, to remove tool marks and prepare the surface for finishing. The finishing process is as important as the turning itself. The vase may receive a coat of sanding sealer, followed by hand-applied oil finishes such as Danish oil, tung oil, or lacquer. These enhance the grain contrast and add depth to the color. Buffing with a soft cloth or polishing wheel provides a smooth, tactile sheen. The completed short vase, with its elongated neck, embodies the balance between form and function. It is structurally efficient, lightweight yet stable, and visually elegant. The method of hollowing from the bottom ensures even wall thickness while preserving the slender proportions of the neck. This approach demonstrates both craftsmanship and innovation in wood turning technique. Ultimately, the finished piece stands as a testament to precision lathe work, where the artisan's control over form, texture, and proportion transforms a raw block of wood into a refined, sculptural object that celebrates both the natural beauty of timber and the technical artistry of turning.